Welcome to Summarize Science. Today, we are looking at how researchers are helping robots see more like humans. Robots need to understand action and movement, not just look at static scenes like a photo gallery. Most robots today use vision systems trained on millions of static photos. This tells them what is in a room, but it doesn't really explain how things move or change. The researchers behind a new framework called DynaFLIP argue that this is why robots often fail at complex real-world tasks. To fix this, the team created a system that combines three different types of information at the same time. It looks at how images change between 2 points in time, the language instructions given to the robot, and something called 3D flow. By aligning these three sources, the robot develops a much deeper understanding of its immediate environment. 3D flow is essentially a map of how every point in a scene moves through physical space. To keep the AI from getting confused, the researchers used a mathematical concept called simplex volume minimization. Imagine a triangle where each corner is a different data type. The system shrinks that triangle so all the data points agree with each other. This ensures that the robot's internal vision stays focused on the most important parts of the task at hand. When the robot is asked to pick up a specific tool, DynaFLIP helps it focus on the tool and its own gripper. Other vision systems often get distracted by bright backgrounds, shadows, or irrelevant objects on the floor. The researchers used heat maps to visualize exactly where the robot is looking while it works. These maps show that DynaFLIP consistently watches the objects it is supposed to be moving. Another visualization technique called PCA shows that the system views objects as whole, solid units rather than just random pixels. The system was tested across various simulations and even on a physical UR3 robotic arm. In real-world tests, DynaFLIP performed significantly better when the items in the room were moved to new positions. This is a massive win because a home robot needs to work even if you've left a mess or changed the lighting in the room. Even when the researchers gave it instructions it hadn't seen during training, it was able to adapt quite well. They found that removing any one of the three data types, like the 3D flow map, made the robot much less effective. This proves that a multi-source approach is the secret to making robotic perception actually work. Looking at the robot in action, we can see successful results where it pours almonds or unfolds a towel perfectly. Competing systems often spilled the almonds or moved the arm in the wrong direction because they didn't understand the flow of the task. DynaFLIP successfully completed all three real-world tasks where others failed. To recap, DynaFLIP moves robot perception from just recognizing objects to understanding the physics of a scene. It uses images, words, and movement maps to create a unified vision for the machine. This results in robots that are far more reliable in messy and unpredictable real-world environments. In the future, this could mean household robots that can help with chores without needing to be pre-programmed for every tiny detail. It marks a major shift from robots that simply see to robots that truly understand the world they are acting upon. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in AI and technology.